All right, well, welcome to episode 3 of Wi-Fi Dirty Jobs. Today we'll talk about industrial versus enterprise hardware. I mean, this is not going to be anything super crazy complicated. I don't plan on frying any brains today. I am Scott. I work for GPA Global Process Automation. We are an industrial automation company. We do everything from industrial automation controls all the way through network and wireless development. You can find me on LinkedIn, Twitter, my blog stop there at industrialwifishop.com. If you want to know more about us as a business, check out global-business.net. Always a good time. So we're going to kick things off with kind of a form factor and physical capabilities comparison of enterprise versus industrial components. And a lot of this stuff is going to be kind of a no-brainer once you see it, but let's just dive on in. So this is what we're, 90% of us are using every day, indoor APs, whether they are internal antenna, external antenna. There are, I'd like for my slide deck to work here. Let's see. There we go. These are all designed for, indoor deployments, hanging from ceilings or the occasional wall mount. You can see by design, they're all relatively similar. They're not super physically deep. They're all very wide and flat. And it's done for aesthetics. It's done for a number of different reasons, but even the external antenna models are built and designed like the internal antenna models, which can make things a little awkward sometimes when mounting for external antennas, but it's no big deal. It kind of keeps things together for the manufacturers as far as the making of this and keeps the cost lower because everything's of a similar design. But when you start looking at industrial APs, and I'm not talking about general Wi-Fi access. Okay, let me go ahead and clarify that. I'm talking about more of your specialized wireless deployments. Design is a lot different. In general, they're not designed for ceiling mount or flat wall mount. They are designed to mount on DIN rail. So structurally, they're built different. Most often they're boxy, but like this first one up here at the top, this little WAGO unit, and then this Phoenix contact unit, they're actually built to be installed on the sides of cabinets because the bottom piece would be on the inside, the top would be on the outside. So they're actually built generally IP66 for environmental containment. The rest of them, they're, like I said, they're built and designed for DIN rail mounting, whether internal. Well, you typically don't see DIN rail mounted internal antennas because everything you want the antennas to be outside the box that they're mounting in. So the few external antenna or internal antennas you see, like these two right here, for example, are actually designed to be mounted, kind of through the cabinet, half in, half out. It's an interesting one because this little guy right here is that second one, and he's obviously the external antenna design, but his neighbor is actually the same model of AP, but you can see how much thicker it is with the internal antenna, and it's sealed, whereas this one right here obviously is not sealed because it's designed to be inside a containment box. And a lot of these are shown with just little rubber ducks on them, but 9 times out of 10 you're not using those. You're throwing on a rubber duck, or you're not throwing on a rubber. You're throwing on a pigtail to run to an antenna that's mounted outside, either to the box on the outside or further out elsewhere. So when we're looking at frequencies, it's a little different there. There we go. When looking at frequencies, enterprise-wise, we have our bands down the center there. 862 to 870 is a very narrow selection of the ISM that you really don't see anywhere but industrial or sensor applications. The only reason I even include it is, with all of the spectrum analysis I do, it is actually one of the options in the Channelizer software suite that you can switch over back and forth to if you have the right antennas and modules for it for 900 megahertz. It will also do the 862 to 870. I've never seen that anywhere enterprise in my years before I came in industrial, and it was rare I ever saw anything 900 megahertz enterprise wise either. And even then, that rare in enterprise, that was a point-to-point shot. It wasn't anything as far as access was concerned. Industrial wise, I say uncommon because I see it a lot, but it's not as heavy as others. Be it point to point, but a lot of data center mesh networks use 900 for its penetration ability. And in some cases, it can actually get a decent data rate to it too for sensors, which is kind of interesting. But other things like LoRa use 900 megahertz too. So it's interesting to see, but you don't see LoRa in enterprise either. So, or at least not right now. 2.4, obviously everywhere. You're seeing it everywhere. The chipsets are so cheap. You know, everybody and their mother's putting together some kind of little sensor, and they're tossing in a 2.4 chipset because of how inexpensive they are. You know, not exactly designing for security most of the time either, but that's a whole different discussion. 5 gigahertz, obviously very heavy in enterprise, common in industrial, but usually for the general Wi-Fi deployments that they're putting over top of factories and whatnot, not necessarily for specialized wireless access for individual controls and things like that. And that's mainly because, you know, the higher the frequency, the more reflection you get. 2.4 has a little bit better carry and penetration value versus 5 gigahertz. And the chipset's cheaper in general. And I have yet, now again, this is me personally, I have yet to run across any 6 gigahertz in any plant that I have been in. You know, and it's emerging in enterprise. It's starting to come out. I'm reading more and more actual deployments, you know, on some of the boards and Slacks that I follow. And it's interesting seeing it coming about, let alone all the discussion amongst all the other wireless professionals on Twitter and whatnot. It's interesting to see it work its way in, and all the advantages of it, and all the problems that are kind of poking their heads up with it in coexistence with other Wi-Fi. But again, that's not something you're seeing in the industrial sector, and it probably won't for quite a long time because it doesn't have that universal utilization to it as far as a frequency is concerned when you're looking at a heavy manufacturing environment. Now, kind of the PHYs comparison. Now, before I get lit up in the chat, I'm not talking about, you know, people not disabling B rates. What I am talking about are actually dedicated radios to that PHY. Every now and again in enterprise, you run across a B radio that somebody still has out there because they either forgot about it or it was just connecting to one rare old piece of equipment. Well, it's a similar instance in industrial, although you do find them a little bit more than you do enterprise-wise. Because one thing you have to remember in the manufacturing universe, you know, a lot of times it's run to fail. Their life cycle of equipment can be 10 to 12 years, even longer, depending. I actually run across a lot of A radios and G radios out in the field. And it's usually as of now because people are actually starting to upgrade old equipment. But by far, what I see the most of are N units. Matter of fact, kind of as an example, these guys right here, these are very common that you find out in the field. These are N, these are not AC. Because the data capacity is just not there for all these industrial applications. Even for heavy usage, you know, you're looking at, you know, 15, 20 meg worth of throughput gets the job done. They're not needing hundreds of meg worth of throughput because this is machine to machine communication, or it's individual device to machine communication. So the need is not there. AC, I have seen on some newer units over the past 2-3 years. Antera has a nice selection of industrial AC radios. AX, I haven't seen anything of yet. You know, and I don't know, you know, as far as Wi-Fi 6, I know some that are coming. But as far as 6 gigahertz, there's nothing 6 gigahertz in the future that I have seen through all my sources and whatnot. But again, you know, a lot of these manufacturers, as far as the industrial applications, are just now starting to produce AC APs. And that's not, again, it's not for necessarily for capacity, it's for more of the stability of the protocol versus older protocols, if that makes any sense. You know what I mean, Jim? Yeah. So yeah, it's I'm not talking about, you know, mass coverage and people forgetting to disable, you know, B rates. So when we look at IoT protocols, you figure, I think the term was coined, you know, back in 2002, 2003 of IoT, but it really didn't kind of catch fire until around 8, 9, or 10 is really when it started becoming a bit of a buzzword out in the universe. I was mainly concentrating here on 802.15.4 stuff. You know, 6LoWPAN, you're just not seeing an industrial. You see it occasionally out there in the enterprise universe. Bluetooth is kind of like your universal, just like 2.4 is for frequencies. Bluetooth is everywhere. And there has yet to be a site that I have not encountered some significant Bluetooth traffic. And it's because a lot of sensors have gone that route, not necessarily mission critical actual operation sensors, but device monitoring sensors, you know, stuff for preventive maintenance and things of that nature. And so it's every time I'm out there doing spectrum analysis, I get to see those nice big spikes in their advertisement channels. It's pretty interesting. You know, you're sitting in the middle of a plant that makes special Nomex fiber for fireproof suits, and you've got all this machinery around you, and you're just seeing ridiculous amounts of Bluetooth. It's not expected, but when you start looking at ISA 100 wireless HART, those are industrial specific protocols. You're not going to see those in enterprise. They're not designed for it, but they are very heavy in the manufacturing world because that's what they were designed for. Zigbee and Z-Wave, yeah, you know, those are common for, you know, all of your home stuff, like Ring sensors and various security systems and all manner of smart light bulbs and whatnot. But again, those are protocols you just don't see in the industrial sector. Now, you know, then you look at your non-standard ones that like run their own, like LoRa and Sigfox or Sigfox. I call that rent a signal, but you know, all that's in that kind of limbo in between, because you don't really see a lot of enterprise LoRa. It's like weather sensors and things like that is what I'm seeing, but it's not necessarily industrial and manufacturing. So it's kind of interesting to see where these things diverge and where they for the most part live. And I think it's fun following all this stuff. Power is another big difference here. So with very few exceptions, you know, just about everything in the enterprise universe is PoE. You may occasionally have the wall wart for something that's in a weird situation with some weird kind of AC power adapter. But, you know, everybody's plugging everything into a PoE switch. That's pretty much how it's running. You know, but it's different in the industrial universe because these radios are not designed for AC power typically. They're DC powered. And so you have to use these specialized power supplies. Now, some of these radios are PoE capable. Matter of fact, this ProSoft is PoE or right here, or DC. With industrial switches, you can have PoE industrial switches, but a lot of cabinets are not designed for that power infrastructure, being that those switches pull that much more power because they're powering other devices. Typically in a cabinet, you've got these 24-volt power supplies, and it's direct, it's DC for everybody. So this is an example of one of my demo boards. You've got your power supply on the left. It's going to a distribution block. And then off that distribution block, you can power multiple devices once you have it down correctly. And it's interesting how many devices one of those small power supplies can actually power with everything that those devices need. And like these industrial switches, I could probably do 2 or 3 more off of that power supply and be just fine. Or I could toss in a small industrial radio and not worry about pulling too much off of that power supply. So it's a whole different dynamic, and it makes you think completely different in the way of power structure planning for the specialized Wi-Fi components that you end up having to put out in the field. Configuration's a bit of a different animal as well. As far as the majority of us, this is what we're used to. We either have, you know, some series of controllers distributed throughout the enterprise, be it in some kind of master local format, with one controlling many, all of our APs coming back and reporting back to these devices in a tunneled fashion so that these guys can do all the heavy lifting, or they're reporting back to the cloud, and you've got some cloud infrastructure that's taking care of all of your CNC for your APs. And the APs are doing the heavy lifting themselves, so they're not kicking all that data, you know, through your pipe multiple times just to pull analytics. So these are what everyone's used to using, right? You know, everyday deployments. I'm an Aruba controller guy, so I mean I use those quite a bit. But the industrial universe is different. You don't have these mass controllers for multiple devices. You have their individual interfaces. You know, this is just a couple examples of ProSoft and that the top one there, that's an Antera. You know, you have to go in and individually configure all these guys. But on the flip side of that, most of these are fire and forget. You're not going to be in these every day making changes and whatnot. If you want to start pulling data and analytics out of the radios for different things, you're going to have to use some sort of API structure that you develop on your own, or find, you know, someone else has already developed, because you're just not going to pull a lot of that from these. Now, some of them will have software that you can use to help you pre-configure the devices before you deploy them, or software that will simplify getting to them, so you're not having to sit there and go and punch in separate addresses and whatnot. They'll give you a little topology that you can click on and then pull up that radio's individual interface. But again, it's not software that's controlling every aspect of your deployment. And then some of them, like this little guy right here, they don't have web interfaces. They have this little dial right here, okay? And this is kind of a common configuration for mesh radios. And these aren't data radios. They're sending and receiving sensor data. So their payload's very small. And a lot of it is just hard coded into the radios themselves. And then all you're really doing is setting your mesh priority. With an example with these guys, this is a RAD 900. You can have up to 100 of these connected, and you know, you just set your little dial, and when you have it set to 01, that is your master, and then you can have up to 98 more of these guys all connecting together by setting their number on the dial and hitting the set button. Now, these do have an optional dongle that you can configure offline. That's what this utility is here at the top. And then once you have that dongle configured, you go plug it in, fire up the radio. It takes the configuration that you set, and that will actually allow you to increase your radio count from 99 to, I want to say, 254 radios that can all then mesh together. And it also will increase encryption capabilities. So it's interesting. So you don't even have a true web interface for that single device. And that's common with this style of radio. These are Phoenix Contact, Banner's similar. and there's some others. But it's that sensor type of radio that's not Wi-Fi. It's still wireless communications. But it's interesting how you have this whole breadth of configuration types, and it's not just punching up a dashboard. It's not logging in to, pulling up a web browser and logging into a dashboard where you can see 500 radios, 1,000 radios, and configure everything from there, because that's just not how it works on these deployments. So use cases, this is the fun stuff. So what are we using all of these specialized radios for? This is the fun stuff, is actually getting out there and deploying them, mounting them up and seeing what they're working on. So this is that one little Phoenix that I showed earlier. This is an external antenna or internal antenna model, and they just mounted it on an L bracket. And so you can see its connections underneath, and it's got its Ethernet and power coming in as 2 separate lines to this L bracket that they've mounted it to. And they mounted it on this panel. It's right behind a big motor. It's got some other power next to it, and this kind of crazy lift arm. But what is all of this part of? And this is the cool thing. This is an internal antenna. This is set up in 2.4 mode, because a lot of these, that's something else I didn't mention. A lot of these radios are dual band, but they're not simultaneous dual band. They're either 2.4 or 5 gig. You can choose one or the other, but you're not going to be operating them both at the same time. So it's kind of an interesting software-defined radio function. So can you guys find them? Can you see them, Jim?
Oh, I see one. Definitely see one. The yellow gives one away. The other one, I do not see.
Okay, so we got 2 of them.
Wow.
And what this is on the right, this is the backside of an industrial elevator. Okay, it's a heavy lift for heavy equipment going up to the 2nd floor. They need to pull control data off of that, but obviously with it's going up and down, Ethernet cables are just not going to do the trick. So the radio on the right probably rises maybe 25, 30 feet, stays in constant contact with its neighbor down below at the bottom, where it's feeding all of its control data into. So they have emergency stop functionality and gathering all the useful data from the sensors that are mounted on the device itself, primarily for preventive maintenance and things of that nature. But it completely eliminates the need for any wires and cables, all the happy things that you want to have wireless there for. But it's interesting because they are built to withstand this in the environment. And if we go back, you can actually see where even underneath they have it sealed, so that all the internal workings of this radio are completely safe from the environment. Pretty cool, huh? This one is actually one that I have worked on myself. This is one of these ProSoft radios, like this guy right here. And this is one that is connected in a building that is connecting to this monster crane. And these are always fun because I enjoy going up. It's normal because I actually have a fear of heights, but for some reason I have no problem going up in these cranes. And so you can see that there's a control cab up here at the top. And there's a lot of automation controls that are part of this, because this guy picks up lumber off of trucks and rail cars, puts it all around for storage, and then starts putting logs into this long apparatus right here, because this is the chipper. So logs are thrown in there. All of the it goes through a debarking process, take off all the bark, and then it heads into a chipper that turns into wood chips. And so there's a lot of functionality to this crane. And they have to pull all this data from the controls on it. But again, this is a point where slip rings aren't going to do it, and standard Ethernet's not going to do it. So they have a pair of these ProSoft radios doing a nice little point-to-point from the top of the crane back to, I want to say it's this little building right down here, and they're able to pull all their data. It's kind of an interesting setup. These radios are actually capable of up to 3 streams. depending on how you configure it. But obviously you can see there's only one pigtail coming off of it. So it's only using a single stream for that connection. But again, it's not like throughput is a huge issue. They're not looking for 100 meg worth of throughput. They're looking for 5 or 10 meg worth of throughput tops. So it's just kind of interesting, all of the deployments you can put these in. This, I thought, this wasn't one of my projects, but a friend told me all about this, and I just thought this was phenomenal. So you can see the radio up here at the top. What you can't see is there's a radio in the bottom. And this is a manufacturing line that puts labels onto drink bottles, okay? So the top half is stationary, the bottom half spins at a relatively high speed. So what they did is they used essentially, slang term, leaky coax, okay? So they have a radio on the bottom, radio on the top. On the bottom side of the disc, they have the radiant cable going around the bottom. They have radiant cable going around on the underside of this. The bottom one spins and it never loses communication because it's only, not even 10 inches from its neighbor. They keep the power levels down, and it's a constant stream of the manufacturing data that they need to pull from these devices. And that's what really all of this is right here. These are the control input outputs for the pieces on the bottom. So it's all being transmitted across this very small wireless connection, but it's replacing slip rings, and slip rings are kind of a rotating contact that can pass power and data. But the problem with slip rings is over time they wear out and they're costly to replace, because to replace them, you have to have downtime. And downtime is what everybody is fighting, because downtime equals no money being made to pay for everything. So this specialized solution to replace the problematic slip rings was phenomenal, because now instead of having a planned downtime of 20 to 30% per year on this machine, that planned downtime is 10% or less for standard maintenance on other parts. So that investment and design has made it well worthwhile long-term for the maintenance of this machine. So it's interesting when you look and the creativity that can be involved with all these specialized wireless communications. I just thought that was really cool. So, this is fun. IoT, that was IIoT before IIoT was IIoT. So we talk about, IoT was coined, like I said, around 2002, 2003. It really didn't become kind of common vernacular until 2010 or so. And then IIoT wasn't really a labeled thing by all the marketing people till probably 2015, 2016. That's when I really noticed it kind of being bubbling up and people throwing around IIoT, because the industrial internet, because the big push of the cloud, which in most cases, you're not going to see cloud control over industrial devices, because we keep that segmented for a really good reason. But these devices were around for a long, long time before IIoT became common vernacular for everybody. And this is interesting because I know I keep bringing this little guy up, but this radio, this 900 megahertz radio, has been around for the better part of 10 years, and when you look at this cabinet that they're being built, you have all of this industrial IO input output, and these are actually outputs because they're going to be receiving data from sensors out in the field. And you can actually see the pigtail hanging down. So if we take a closer look, whoop, wrong direction. This is that radio module that I've got right here, this guy. And he's hardline connected to all of these industrial IO, be it digital or analog. And that IO is coming out of these serial connections to the controllers. This is all mainly power. The controllers are actually in another cabinet. So all these hard lines are leaving this cabinet, going into another cabinet. But for this particular deployment, once it was finished, there were 60 or 70 other sensors all sending data in to this closet. And this has been going on for 10, 12 years, long before IIoT became a thing. Does that make sense? So it's interesting to see that so many people think that these are just brand new ideas, and they're not. This has been around a long time. And another proof, I thought this was cool because I can't help but get spectrum analysis because I'm a junkie. This is actually a spectrum grab of these radios in action. They use direct sequence spread spectrum. You can see their coordinating frequency, which is just a smidge below 912. You can kind of make out some of your columns going down, and over in the navigation column is what my favorite, because you get this nice, pretty striped design as they're hopping across. You can see the smaller peaks and some actually little heavier utilization points from their data passing. But you can see, because of the protocol, they're not overcrowding the spectrum at all. You know, this particular capture was probably of 8 or 9 of these all talking together. So they're passing their necessary data, and they're not over polluting the frequency. So a ridiculous amount of these can coexist together long term, which is really nice. But you know, we talk about SCADA and we talk about 3G. You know, these cellular SCADA devices in 3G have been around 15 plus years, long before even IoT became the household name that it is today. So it's interesting, again, to see all these people that think this is brand new stuff, when the concept and the reality of it have actually been out in the field for a long time, if you bothered to pay attention to it. So all of these specialized kind of wireless applications for industrial and manufacturing and big agro, and it's just insane how long they've really been out there. And then a lot of us in our field are really just kind of starting to wake up to a lot of it, because you're not out in it every day. You know, and it's not something they teach in the standard course of the CWNP material. The CW ISA material does touch on it a lot heavier, but you still don't get a full, you know, grasp a lot of these things, because it does push a lot more onto the integration side with APIs and stuff. But you know, the actual physical aspect of it is just as, or if not more important than the integration on the backside, because if it doesn't work at all, then what's the whole point of any of it? So I thought you guys would enjoy this, a nice comparison of enterprise gear versus industrial gear. It's a lot of fun to work in. And if any of you guys ever get the itch, I'm telling you, get out there. The challenges are a lot different, and it's a lot of fun, especially when you get things working that you didn't think were going to work, because you can get really creative with what you're doing out there. I know I enjoy it, and I know there's not many of us, but there's a few of us that work in this general area, and we have a good time with it. So that's what I got, guys.
Very cool. Thanks, Scott. That was really awesome. And you know, the first thing that came to my mind when you showed those, at least the Wi-Fi APs, is how do you do a design? Like, do you have to go into a bunch of autonomous APs and set channel and power manually?
Correct.
Oof, that's tough.
Yeah, you have to. It's all manual configuration. I mean, you can with some of that software, you can kind of pre-configure a lot of it and then just kind of push it out. But the vast majority of it, you're individually configuring every piece. But on the flip side of that, typically you're not putting out 500 of these at a time. You know what I mean?
Right.
So your actual volume of radios is much lower. So there's that kind of give and take.
You also, you know, you do more work up front, but you have a more robust network. You know, if that AP's up and running, it doesn't need anything else. It's up and running. So no central point of failure. Some good questions from the audience. I'm going to go through a few of these. And I think, Heather, maybe we have a little extra time without Eric today. Is that right?
Yep, that's correct.
Sounds good. So Forrest is going to start us off. He's asking, what's the purpose of DIN rail mounting? Is it for mounting in server rooms or an MDF somewhere?
No, the DIN rail mounting is actually in the cabinets out in the field. So these are not radios that you put in an MDF or an IDF. These are actually in the industrial cabinets out in the field. So, I didn't even think about kind of getting location pictures of where these cabinets reside, but it's that's where all of the other equipment is mounted. So all of the controls, all of your power for those controls, your input output structure, and various other pieces of the puzzle, that design already exists, and it has for 30, 40 years. So they were designing the radios to fit that environment. Does that make sense?
Yeah, makes sense to me. And a couple good questions here from Nick. First one, he says, what tools do you use to detect the various protocol types in the environments?
Well, typically I have to look up a lot of what that the radio is specific from the manufacturer, because there's not really, unless they're following 802.11, there's not really a protocol analyzer that you can use over the air for these things, which is one of the reasons I rely on spectrum analysis so much. Because if nothing else, I can get the raw RF values of what that radio is doing. Because so many of these, Phoenix and ProSoft, they use a lot of their own proprietary protocols, but even then, they're still building them on top of DSSS and some of these things that we're used to seeing. So in the raw RF portion, we can recognize that very easy. But when you get down to trying to troubleshoot non-standard protocols, you rely heavily on the documentation and the manufacturer of that device, because that's all you really can do at that point.
Right. And next question from Nick. Do you find that a lot of industrial products that use 802.11 for Wi-Fi are set up badly from a Wi-Fi best practices point of view? And then he's got an example of a cooler they found the other day that was set up with 80 megahertz wide channels transmitting at full power. And that's probably just the default config of that radio, unfortunately.
I find that all the time, because 8 out of 10 times it's not a wireless professional setting them up. It's they're given to an OT engineer or an E&I guy, electrical instrumentation guy, and these are not wireless educated people. They'll read the book real quick. They'll figure out how to put an IP address on it, how to get basic functionality of it up. Do they know the pros and cons of setting wider channels versus narrower channels, and doing a channel plan? No, they don't know any of that. So 9 times out of 10, they're going to leave all of that stuff at defaults. They're going to put that IP address on it. They're going to get their basic functionality up. Once it's connected and pulling what they want, they don't care. They walk away.
And that's kind of how they're deploying other IoT protocols too. So, right, they probably are expecting it to be sort of turn it on, some very basic config, if any, and off you go.
And to be fair, some of these industrial radios, they have that set as default, which makes no sense to me whatsoever. Setting everything for default on wide channels is just bad practice from a manufacturing point of view, which there's only so much you can do about that. But fortunately, all the clients that I get that I work with, that's one of the things they have me go through and look at, is to make sure all their stuff is set right. Because a lot of times too, this has to coexist with their corporate wireless that's in place too, often also in place poorly, because standard IT guys don't know what to do in that OT or heavy manufacturing environment. So you have two groups who don't know the best practices for each of these. One doesn't have much of a background in it at all. The other has a background in one side of that, but really not how to adjust it for those conditions. And it's the perfect storm for really screwed up deployments, which if you've watched part 2 and part 1, I showed a bunch of pictures of. So
good call back there. So changing pace a little bit, Noli here is asking about security issues with this stuff. What are your concerns and some common issues you see?
It's interesting because what I have messed with, a lot of it is just 802.15 base, so they're capable of doing the 256-bit encryption or 128-bit encryption. And I will say more often than not, even the guys who don't know what they're doing will check that encryption box, which that's good. But on the flip side of that, it's 802.15.4. It's your average sniffer is not going to pull much out of that to begin with, unless you have those specific radios and you've got some programming skills on the back end. Where I find more security issues is general Wi-Fi with poor deployments. And it's not so much, whether or not they're using WPA2 or whatnot, but it's the physical location of the APs where everybody can grab it, touch it, feel it, do whatever they want to it, or they can get hit by industrial trucks running around. So it's more of a physical security issue than a logical security issue. Other than the fact that apparently everybody in the industrial universe is afraid of .1x authentication. And so everything is a pre-shared key, and everybody and their mother has that pre-shared key.
Yes, including probably a lot of former employees no longer.
Correct.
With the
because
company.
there's no policy in place to change that periodically.
Right. Yeah. And that's not, that's a common thing, and unfortunately in enterprise environments too. Once you get locked into a PSK and put a few thousand clients on the network,
right,
good luck ever changing it. So. Question from Rick. He says, do you see CBRS/private 5G growing in industrial environments?
I do, and there's a whole subset of people that's all they do is CBRS. CBRS is much bigger in Europe than it is here, although it is growing here. I've got a few contacts that CBRS is all they're doing. One of our big clients, a very large paper company, actually has 2 of their plants going through and essentially doing long-term proof of concepts. One plant is going all CBRS, private cellular. The other plant is going all Wi-Fi, all wireless, standard wireless protocols, to see what's more cost effective, what's more reliable over time. So it's interesting. So large companies are starting to pay more attention to CBRS. And some of them, like I said, are actually starting to put money into seeing what's going to be better for them. And that's a pretty big deal when you're outfitting an entire plant with CBRS to play the what if game versus Wi-Fi protocols to see what's going to work better, because that's a lot of money to invest to do that. But when you're thinking long term and you've got 20, 30 plants across the country, it can be worth it.
Yeah. Yeah, that's really interesting. Yeah, and once you've made that decision for a plant, there's no turning back. There's no rip and replace.
Once you make that initial equipment investment, because that's where all the money gets tied up, is the hardware.
And last question here from Andrews. How hot do industrial APs run power-wise? Are they different from enterprise? I ask because in our environment, we have what I suspect is an industrial AP completely burying some enterprise 2.4. Of course, it's on the wall that separates the office from the shop, but we can't find it. I've been there. Yeah, that's no fun. You find it in the Wi-Fi scanner everywhere. It's out in the parking lot everywhere you look, but you can't find it when you go inside.
By default, these guys, actually, no, by default, these guys are max power, which is 1 watt. By default, I found this out the hard way. By default, these 900 meg transmit at 1 watt. So 1 watt plus whatever passive antenna you're putting on there, and you are screaming out signal everywhere. And which would make sense if the radio that you're talking about was left at default, so you can see it everywhere, but can't find it because it's hidden somewhere. And it's just screaming out there. This guy right here, I have this one in my other lab one is a pair when I do testing, and I have 2 dB rubber ducks that I put on these things. And through the magic of harmonics, I didn't realize it, but I was essentially DOSing my garage door opener. So I had these running for a week and couldn't open my garage and couldn't figure out why the hell why.
Well, those are like 300 megahertz or something.
Yeah, well, I figured it out after a while, and apparently my garage door is running on like 306 or 308 megahertz because of the way the harmonics work. I wrote it all up in my blog if you want to see it. I think it was the last one, but that was an interesting thing because harmonics, another thing that is not taught in the CWNP lineup, which I'm not saying it's a super common thing, but it's something we need to be aware of. And the only reason I figured it out is because one of my coworkers is an old Navy radio guy, and they had that problem, not on a regular basis, but common enough that everybody had to be aware of it. So we started talking, and it led me down that road. And sure enough, that's what it was doing. I had, essentially 3 watt of 900 megahertz transmission crushing my little 302 megahertz garage door opener that barely transmits on a few milliwatts. So it's interesting stuff.
Yeah. Yeah, actually harmonics, it's not a common topic, but even in the enterprise, a lot of enterprise APs are shielded against harmonics coming from nearby cellular transmitters that could be disruptive in, I believe, 2.4 gigahertz. But there's so much noise there anyway now. That... Yeah. And actually, we got a late question, so maybe we'll just wrap up with this one. Nick is asking, how much risk is introduced into industrial environments by badly configured wireless products? Are industrial products built with lots of fail-safes in case the wireless gets so bad that it becomes unusable?
Okay, so this is opening up a whole different debate here, because a lot of times wireless is not used in mission critical safety issues. Okay. And specific for that reason, because there's a lot of different things that can generate RF interference, especially in an industrial environment. And again, this is why I do so much spectrum analysis, is to find those culprits and either be able to help them eliminate that or to work around it. Because if you don't know it's there, how are you going to defend against it, right? And so there's a lot of mission critical stuff that's not put on wireless specifically for that. And that's, I would say, probably 80% of what I see wireless wise that is not general Wi-Fi access is not tied to mission critical. If it shuts down and dies, the whole process shuts down. But there are some fire safety systems that are on wireless. They tend to run in licensed frequencies, but they're still subject to this non-Wi-Fi interference, out there. So it's always good to know what's going on in your airspace, so you can own that and make adjustments from there. And the fire safety stuff, I've got to say, it's all mesh and proprietary and whatnot. I have yet to see one of those fail or hear of one of those failing in the 7-8 years that I've been on the industrial side. I have seen some equipment that have been wire or set up with wireless e-stops, emergency stops, and those haven't had an issue. But those are also the companies that take the time to own their airspace, so they know what's going on, to keep anything from interfering with those. So it's kind of a tricky debate there. It's one of the things that makes some companies shy away from using wireless, but there's so many use cases out there for it that aren't life-death mission critical, that can save money and be every bit as reliable as hardline, if not more so. And that example of the slip ring replacement for that bottle line is well, it's a prime example of that. It's not going to hurt anybody or anything like that, but it sure does save them a lot of time and money for planned maintenance.
Yeah. Yeah, that could be a whole webinar, but I saw a example of a customer using Siemens IPCF, and it is PCF, just a little bit with a little bit of extra special sauce in there to control a overhead crane arm. And of course, there was significant safety risk with that, but they had emergency stops and things like that. They're constantly checking latency. If latency got out of spec, the thing just stopped. So
Siemens is they're kind of ahead of the game, more so than a lot of these guys in that realm, and they're responsible for a lot of innovations, and they use a lot of their own secret sauce in that. Me personally, I find their industrial wireless stuff pretty impressive. However, it's also very expensive because they're very proud of their stuff.
Gotcha. Good tip.
But as with any of this, it's all going to be situation specific. Everything. So you're not going to find a place that's all that, like in the enterprise universe, you've got people who standardize on Ruby, you've got people who standardize on Ruckus or Cisco, and everything is like that. You're not going to find that in the industrial universe because everything is so much more situationally specific. And not one manufacturer makes radios that can cover every base.
Right. Yeah, makes sense. Okay, Heather, I think we're all wrapped up.
All right, awesome. Well, thank you, Scott. Wonderful as always, already seeing really great feedback in the chat about your sessions. We love them. So I'm sure we'll guilt you into a part 4 through 100. And thanks to Jim. Thanks to all of you for being here today. And we will see you again, same time, same place next week. Have a great rest of your week, and we will see you then.
Thanks, everyone.
Thanks.